Great, thank you. And thank you for having this topic midway the morning. I think trying to sort of ground us a bit from all the science you saw there in the earlier sessions. So I'll bring it actually back to the here and now even. I am also a scientist with a scientific background, but currently working very much on the interface of climate science, policy and practice in the Red Cross Red Crescent, as was mentioned. And that forces me to always make those connections. 10, 15 years ago, people really asked me all the time, why is the Red Cross worrying about climate change? That's no longer entirely the case, but I still get that question very often. And I think this poster that the French Red Cross prepared for the Paris summit, just as we have another ratification ceremony in New York, good to remind ourselves of that success. This was the poster they prepared going into that summit. And for those of you who don't read French or for who this font is too small, it basically says something like, we'll always be there to save you if needed, but we'd much rather prevent that from becoming necessary. And I think that sums up nicely how we engage on climate today, partly trying to understand and advocate about the risks that we might confront in the longer term, but also thinking about how to anticipate and reduce risks in the nearer term. So I'll talk a bit about those human impacts, and those human impacts clearly, and I think you all have that experience individually as well, but we certainly also get that from the most vulnerable places. Those impacts are visible today. Not everything that is ascribed to climate change is necessarily also anthropogenic climate change, but the patterns people are seeing are real. And what they are seeing now is going to move into the more abstract notion of what we will eventually face with the 1.5. And what these people are experiencing today in terms of impacts will actually determine in what state they will be coping with the impacts at 1.5. So instead of thinking about a sort of abstract hypothetical world at 1.5 and a world at 2 degrees, we need to look at these things as starting from the reality of today and confronting choices that have to do with much more than just climate on its own. And I think that's also a useful reminder as we talk about the Paris Agreement. We had several of these other international agreements last year, including these Sustainable Development Goals that were briefly mentioned earlier. But also a Sendai Agreement on Disaster Risk Reduction, a World Humanitarian Summit. Humanitarian costs rising from about 25 billion a year now to 50 billion a year by 2030. So a similar scale type of tens of billions of orders of billions of international money that need to be moved around to deal with these questions. And of course, these things all relate. So the question is, how do we look at that together? And I will argue that in order to understand this 1.5 degrees question from a perspective of the decisions we have to make today, we need to look at this as risk management. And I was personally very, very pleased with the way the IPCC Special Report on Extremes first framed this concept of risk, and it was then carried over into the AR5. And to me, this is a very helpful way of bringing these things together. It also emphasizes that what we have on the, let me see, do I have a pointer here? What we have on the left here, natural variability and anthropogenic climate change feeding into the hazards, is only one part, and vulnerability and exposure are as critical to understand the risk, which then also, through the impacts, feed back into both the vulnerability and exposure as well as the climate changes we're facing. We've seen various varieties of this figure. I think this is the working group 2 one. I put the 1.5 line in. The main reason I want to show it here is not to go in depth on all of these risks of all of these impacts, but also already to show you that we can't really think about one line that we now decide on when we choose an emission scenario that we'll get in terms of 1.5. So what we're confronting, and what I'm confronting if I advise the people in the International Red Cross Red Crescent system, or when I talk about these things with these local communities, is basically this whole envelope of options, even starting already at the global temperature. And then going from the global temperature, of course, with each of the potential outcomes in terms of global temperatures, you then get whole ranges of hazards coming from that, which then translate into actual impacts, which again is already a physical translation into impacts on, for instance, hydrology and the risk of floods, but then also human impacts in terms of exposure and vulnerability of human systems. And And I should note that the uncertainties in terms of what we'll be confronting at 1.5 well, it might be in 10 years, as Richard told us, but more likely 20 or 30 or 50 years. The uncertainties in what will happen to exposure and vulnerability are probably way higher, maybe with the exception of the tipping points, than the uncertainties that we already heard about on the climate and the physical side. And finally, a critical point is that this is all dependent on our choices on risk management. And I'll talk you through a few examples that illustrate how critical it is, how we look at these choices today. And it's not just a choice about whether we choose a 1.5 or a 2 degrees world. It also is the choice about how we deal with risks in the current world and in a path towards 1.5 or towards 2 degrees. So let's take one of these examples where we actually have a fairly easy connection. Sonia already mentioned, with heat, there's a pretty straightforward connection from the global average temperature change to the regional temperature change to the distribution of extremes with this sort of a neat PDF that then gives you a change in probability for an event. I wanted to acknowledge Miles' original paper. We're actually now doing this in fairly real time because we're seeing these questions coming certainly in my world, in Red Cross or Crescent, whenever a big disaster occurs. So was that climate change? So we're now able to answer those questions relatively quickly. But that's still at the level of the hazard. So one thing that in the IPCC Special Report on Extremes we already noted that the context of the heat waves, this was a case study on heat waves in Europe. So on the hazard side, we get the likely increase in heat wave frequency and very likely increase in warm days and nights across Europe. This was the SREC result. But actually, if you look at what made this such a deadly event in France, for instance, you're looking at the risk factors on the left. And if you look at management options, you're looking at the options on the right-hand side of this slide. So in order to understand what really happened, this is the sort of thing you need to look at. In France, they put in a massive effort to now better manage heat wave risk. And they did much better in subsequent heat waves. The Netherlands, after 2003, took another one in 2006 before they initiated a national heat wave plan. Probably because that country still considered itself less at risk of heat waves, even after the 2003 one, which also killed more than 1,000 people there. And then look at this one. So this is the reality we then face. We're still looking at the hazard data. This is the sort of data that we could also crunch from our 1.5 scenarios. But let's look at what happens if we get these statistics out of our 1.5s and take a current case. What you see here on the top left is this comes out of the KNMI Climate Explorer. So you take ECMWF forecasts. We did this around this time. And we saw this big heat wave that most of you probably experienced, those of you in Europe, 2-3 weeks back, we saw that heat wave coming. And Netherlands Red Cross, in that case, puts out advisories, call your grandmother, make sure she drinks 6 glasses of water a day. When public authorities issues these warnings, now that we have a heat wave plan, in hospitals and elderly homes, there are standard protocols that get started. In this case, public authorities decided not to issue a warning. Because they got this, which is the mean temperature for the day. They thought, oh, it's going to be very hot during the day. But we're already in September, and the nights are going to be much cooler. And we know that actually it's the nighttime temperatures that are very defining for mortality. So now that we're in September already and it's going to be cooler at night, it's not going to be much of a problem. Without even looking at the data, so here we plotted the minimum temperature that was expected for that week. And you actually see that it was, in the end, it was the second warmest night of the whole summer, including July and August in the Netherlands. So this is the sort of misperception and actually adaptation in terms of how we even look at the data in order to understand how to trigger risk management responses that will be very determinant in terms of how we actually cope with these risks. I just wanted to run through this very concrete example to show you how to look at the sort of statistical distributions that come out of a 1.5 scenario. It's this sort of decision making that in the end determines what sort of human impacts we will face. So let's look at a much more complex case. As I said, we started on the easy one on the hazards with the heat waves, where we can do the statistics relatively easily. Drought in East Africa, much more difficult case in terms of attribution to climate change. Of course, the observations and the models are even going in different directions. So from the perspective of, again, those communities asking me that question on climate change, probably a reality of 1.5 further increasing the uncertainties that they have to cope with. And that is already a risk management problem on its own that we need to acknowledge as the piece of how we frame this 1.5 problem. So again, let's try and bring it back to simpler hazards than this whole question of how big was anthropogenic climate change. We did have a signal that might be comparable to something we could get out of our models for 1.5. In this case, a seasonal forecast that we got in October 2010, well before we got the hundred thousands of people dying in Somalia, for instance. So this was the global seasonal forecast map. This was in the end a set of emergencies that we responded to in the period covered by the seasonal forecast, indeed including this Horn of Africa drought. Now, the humanitarian community basically started funding real operations on the ground after the first people were dying and were showing up on the front pages of newspapers, about 5-6 months later after this information. Around early 2011, we started seeing this sort of information. So let's zoom in on, this is hazard information, right? This is still expected lack of rainfall. Still not even drought, but okay. Translates into drought in this case. So this is the food security mapping with the risk classification from the humanitarian side, where the dark red is the full-out famine. This is people dying of hunger every day. And if you look where these problems occurred, that's not correlated at all with where the rainfall was lacking. First of all, one important thing is that it depended on what happened in previous seasons. But if you would map those geographies, you would not see exactly where people would die out of the rainfall. This is southern Somalia. So the whole of Somalia is by far the worst affected, particularly southern Somalia, where there were terrorist groups active, prevented aid from reaching there, actually also prevented donors even from wanting to provide lots of aid because they were worried that it would get into the wrong hands. And of course, a failing system that could deliver to the most vulnerable groups. Whereas in Kenya, where rainfall-wise the situation was very similar, almost no one died. So again, how do we understand the human impacts of 1.5 degrees on the basis of this sort of hazard information, even if it's as clear as the seasonal forecast, which probably it won't be in terms of 1.5 in East Africa. And finally, what you see here then is southern Somalia mortality. This was of the order of 260,000 people. Let me go back. There's also a massive differential impact within those places. So under child mortality, for instance, under 5, child mortality was way higher than average mortality. And we often see gender disaggregation as well in those places. Those are things we can act on. There are strategies that we can employ. So vulnerability in this case was clearly the driver for the human impacts. But I should also note that the climate information is a relevant and potentially actionable piece of information. So that is, I think, something to remind us here. It's not like climate is irrelevant. Climate is in the end triggering the mortality, but it's just not the one factor that tells us what's going to happen. I'll skip this slide in light of, I'll actually quickly go through it. So in terms of research priorities, what do we need on this path towards 1.5 degrees or towards 2 degrees, as I would say? So it's risk information for decision makers. And I think it's important that we think about this question not just as these abstract worlds, but in terms of what do we need to know right now to make certain decisions regarding mitigation pathways and regarding risk management. Better insight in system dynamics, especially thresholds. There are cases, for instance, where subsequent seasons are the problem. Need to build that in. And a focus on resilience, including anticipatory, absorptive, and adaptive capacities. The key defining cases I just showed have to do with those sorts of elements of systems rather than purely with our top-down climate modeling perspective on this. Finally, this is only 3 quick slides, so I'll stick to time. And we heard several warnings about this morning as well. Risk management itself, including our mitigation and adaptation strategies, may have human impacts. We heard about food versus biofuels this morning. Another example, Haiyan, the big cyclone in the Philippines. Of course, we don't know much about how climate is affecting storms in that area, but of course, an already risen sea level results in a bigger storm surge, which killed 93% of the people in the impact of Haiyan. There was an immediate call for no-build zones in the places that have been affected. That has a massive impact on those people's livelihoods and lives and the social fabric of those societies. It's a big choice to make. Those are the sorts of choices that are being fed by this information. And finally, there was a question about geoengineering in terms of negative emissions. I'm hearing big communities now almost taking for granted that solar radiation management will be unavoidable if we want to stay below 1.5 degrees. And there's very little attention for the human impacts, the side effects, the unanticipated, unintended consequences of that solar radiation management, for instance, by shifting monsoon systems. So again, I think an under-researched piece of the puzzle here for 1.5 degrees. Thank you.